So good afternoon to all of you. In the previous session, we discussed about the DC circuit and Ohm's law. Is it right? Let me try to revise this concept. A DC circuit means what? A closed path followed by the direct current. We call it a DC circuit. So in the DC circuit, there are three essential parts. One is energy source. Can anybody give me that why that energy source is required? Why that energy source is required? What is the
create potential difference?
Absolutely correct. Let me repeat once again. Suppose you just consider that this is a conductor having a particular length. Can the current will flow through that conductor? Yes or no?
No, sir.
No, sir. Why? Because we have not applied that energy source. And this energy source, when it is connected in between these two terminals of this conductor, this energy source will create the potential difference. And this is the mandatory condition to the flow of current. This is the concept is that. Get it, my point? If I consider that this is the resistor, just by simply considering the resistor, no current will flow through that resistor. Is it right? But when we connect the energy source, DC energy source, in between the two terminals of a resistor, this energy source will create the potential difference. Once the potential difference is created, there is a movement of electrons from negative end towards the positive end. And once the movement of electrons occur simultaneously, that electric current it flows through it. Get it, my point? So this is the main function behind that energy source is there. Okay. Then the second part is load. As I said that there are total three types of loads are there: resistive load, inductive load, and capacitive load. But which types of load it is used in a DC circuit?
Resistive
Resistor.
Out of these three, resistive, inductive, capacitive, only resistive type of a load it is used. And I think I have given this question to you. I will ask that answer of this question in the Monday's lecture. Get it, my point? And the third essential thing is the connecting wires. If I just simply consider the conductor, and when I want to connect in between these two end of that conductor, when I want to connect that energy source, definitely the connecting wires are required. Get it, my point? So if you see that the simple structure of the DC energy source, so this is the resistor, these are the two terminals of a resistor, and this is the external energy source, and we have to connect through the connecting wires. So this energy source, DC energy source, having its a particular fixed terminal, that we call it's a positive terminal and the negative terminal. Get it, my point? In this way, the circuit becomes closed. And when the circuit becomes closed and the potential differences exist in the circuit, these are the mandatory conditions to the flow of current. There are two conditions are there to flow that electric current. One is the circuit path must be closed. And second is the potential differences exist, then and then the current will flow through the circuit is there. Simple thing is that. Okay. Now, through this diagram, the three essential parameters, fundamental parameters of that electric engineering comes into picture. What are these three parameters? One is a voltage, second is a resistance, and third one is a applied voltage. We call it a potential difference also. So now, in between these three parameters, one fixed relation is there. And that relation was determined or was discovered by one of the German scientists, and that relation is known with his name. We call it Ohm's law. Get it, my point? So the relation between that applied voltage, current, and load resistance are in a DC circuit was first discovered by the German scientist George Simon Ohm, and this relation is known with his name. We call it Ohm's law. This relation we call it Ohm's law. So this Ohm's law is the relationship between applied voltage V, load resistance R, and the current I is there in the particular DC circuit is there. Now see that what is the statement for that Ohm's law. If you see that when I consider that the conductor, is it right? And when that external energy or that DC energy source, when it is connected in between these two terminals of that conductor, this DC energy source will create the potential difference and the current will flow through it in this conductor is there. Get it my point? It means that when I consider that the conductor, it has its a fixed length, it has its a fixed area cross section, it has its a fixed temperature. It means that everything is fixed when I consider the conductor and when this conductor is connected to that DC energy source. It means that the physical condition of the conductor is always remain constant. Then the statement is like that the potential difference between the ends of the conductor, ratio of potential difference between the ends of the conductor to when the potential differences exist, definitely the current is flowing. So the ratio of potential difference between the ends of the conductor to the current flowing between them is a constant. But when provided that physical condition of a conductor do not change, that's why V divided by I is equal to constant. And this constant of this conductor is nothing but the resistance of that conductor, because when I consider this conductor, it has its a fixed resistance. And the resistance of the conductor is the property of that conductor. It means that when I take the piece of a silver, it has its a fixed resistance. When I take the piece of a copper, it has its a fixed resistance. When I take the piece of gold, it has its a fixed resistance. Is it right? So that this constant is nothing but what? It's a resistance is here. Get it my point? Now, this equation V divided by I is equal to constant, and constant we can replace with R, or I can also remember that Ohm's law by the equation V is equal to IR. Get it my point? And the resistance means what? The resistance is nothing but the resistance in between these two terminals of the conductor. Because between these two conductors, we have connected that DC energy source, so that these two conductors, these two ends are very important. Is that? Get it my point? Okay. Now, when we consider that the resistance of this conductor is fixed, it's a constant. So according to that Ohm's equation, V is equal to I into R, out of that R is kept constant. So we can easily say that the voltage is directly proportional to the current. Means as the voltage increases, the current is also increases with the same proportion. What I say that as the voltage increases, the current is also increases with a same proportion. If in a particular circuit, if the current is not increases in a proportion with the voltage, can we apply the Ohm's law to that circuit? Are you clear with my question? Once again, I will repeat. If in a particular circuit, current will not increases in a proportion with the voltage, then can we apply the Ohm's law to that circuit?
No.
No.
Because
No, sir.
what the Ohm's law gives that V is directly proportional to I. म्हणजे करंट हा कायम व्होल्टेजच्या प्रपोर्शन मध्ये असला पाहिजे, ही मॅन्डेटरी कंडिशन आहे ओहम्स लॉची. जर एक पर्टिक्युलर सर्किट मध्ये करंट जर व्होल्टेजची प्रपोर्शन मध्ये नसेल, then we cannot apply that Ohm's law. This is the limitations of Ohm's law is here. So what is the mandatory condition? Two mandatory conditions are there to apply that Ohm's law. One is resistance must be kept constant, and the second is current must be in proportion with the voltage. Then and then we can apply that Ohm's law, otherwise not. This is the fixed rule is there. Get it my point? Now here I say that just consider that one simple circuit. One resistor, this is the terminal, these are the two terminals of the resistor. Let's assume that point A and point B, and these two terminals of resistors are connected to the DC energy source with the connecting wires. Now DC energy source is a 5 volt, resistance having its value of 100 ohm, and when it is connected, when the closed path is formed, definitely the current it flows. And we know that the conventional direction of a current is always from positive terminal of a DC energy source towards the negative terminal of a DC energy source. Get it my point? Now here we know that resistance value 100 ohm. We know that applied voltage value 5 volt. Can we calculate that how much current can flow through this particular circuit? Of course yes. This is the application of Ohm's law, because we have applied that Ohm's law actually to calculate the parameter out of these three parameters, that is nothing but I. It means that out of these three parameters R, V and I, if you know that any two parameter, I say that any two parameter, then by applying Ohm's law we can calculate the third parameter. Now in this case we don't know that current value, but we have that value of R and V. It means that we can apply that Ohm's law. The equation of Ohm's law is V is equal to I into R. Put the value of voltage and resistance in that equation. Now when I want to calculate that I, then definitely I need to transfer these 100 terms towards the left hand side. So it should be divided to 5. So I is equal to 5 divided by 100, which is equal to 0.05 ampere, or we can simply say that 50 milliampere. Milli means 10 raised to minus 3. Get it my point? So this is about that Ohm's law is there. Now see that the limitations of Ohm's law. As I rightly mentioned that when we want to apply that the Ohm's law, the two things are mandatory. What are these two things? Number one, resistance must be kept constant. Number two, current is always in a proportion with the applied voltage. Out of these two, if one of the case is not followed, then definitely we cannot apply that Ohm's law. म्हणजे रेजिस्टन्स कॉन्स्टंट आहे परंतु करंट प्रपोर्शन मध्ये नाहीये, आप ओम्स लॉ अप्लाय करू शकत नाही. करंट प्रपोर्शन मध्ये आहे पण रेजिस्टन्स कॉन्स्टंट नाही. वी कॅनॉट अप्लाय दॅट ओम्स लॉ. Are you getting my point? These two things are mandatory to apply that the Ohm's law. So by using these two parameters to apply that the Ohm's law, the certain limitations of that Ohm's law is there. See that the limitation. Ohm's law is not applicable to unilateral electrical elements. आता हे unilateral electrical elements म्हणजे काय? For example, diode. As I think you are aware about that particular component, diode. The Ohm's law is not applicable for unilateral electrical elements like diode, as they allow the current to flow through only one direction. या डायोडला युनिलॅटरल एलिमेंट का म्हणलेलं आहे? कारण इट ऑलवेज फ्लो द करंट इन युनिक डायरेक्शन. दॅट्स वाय वी कॉल इट्स अ युनिलॅटरल इलेक्ट्रिकल एलिमेंट. मग असे जे काही पर्टिक्युलर कॉम्पोनंट्स आहेत जे फक्त एकाच डायरेक्शन मध्ये करंट फ्लो करून देतात, सो वी कॅनॉट अप्लाय दॅट ओम्स लॉ. दिस इज द लिमिटेशन्स ऑफ ओम्स लॉ इज देयर. गेट इट माय पॉइंट? इफ यू वांट टू सी दैट, just check it here. This is the symbol of a diode. Is it right? I think you are aware about that the symbol. This symbol, in that this arrow indicates the direction of a current. Means diode can flow the current only in this direction. But if you see that characteristics of a diode, then you can observe that here I have drawn that the characteristics of a diode. If you see that from this starting point, now this is the 0 point. If you see this up to this point, we increases the voltage but the current is not increases in a proportion with that voltage. That's why we are not having the straight line in between the voltage and current from this point to this point. Get it my point? That's why we say that here we cannot apply that the Ohm's law. It means that that particular diode, it's a unilateral element. We cannot apply the Ohm's law. This is the first limitation of Ohm's law is there. Get it my point? Now come back to that point here. Ohm's law is also not applicable to non-linear elements. The non-linear element means what? The non-linear elements are those which do not have the current exactly proportional to the applied voltage. That means the resistance value of those elements changes for different value of voltage and current. Now, when the resistance value is going to be changed, how I can apply that the Ohm's law to that particular component or that particular circuit? For example, transistor, non-linear element. Now see that. What is that transistor? Let me show that the symbol of a transistor. We know that the transistor, I think you already have that little bit idea about the transistor. The transistor is a 3-terminal device, and its resistance is depends upon applied voltage. It means that the resistance is going to be changed. And if resistance is going to be changed, definitely we cannot apply that the Ohm's law is there. This is the second limitation is there. First one is what? We cannot apply to that unilateral electrical elements like a diode, as they allow the current flow in a one direction. And second is what? We cannot apply the Ohm's law to non-linear elements. And non-linear element means what? Its resistance is changes with respect to voltage and current. For example, transistor. And the third limitation is, it is not necessary that all conductors obey the Ohm's law. म्हणजे भरपूर असे गोष्टी आहेत की प्रत्येक कंडक्टरनं Ohm's law ओबेच केला पाहिजे असं नाहीये. It is depends upon that conductor. Are you get it my point? Some conductor may show that Ohm's law, some conductors may not show that the Ohm's law. It is the property. आणि त्याच्यासाठी दोन कंडिशन आपण ठेवलेल्या आहेत. एक रेजिस्टन्स कॉन्स्टंट असला पाहिजे आणि करंट हा व्होल्टेजशी प्रोपोर्शनल मध्ये असल्या पाहिजेत. मग ह्या दोन प्रॉपर्टी जर कंडक्टर ओबे करत असेल, फॉलो करत असेल, तर डेफिनेटली त्या कंडक्टरला ओम्स लॉ हा ऍप्लिकेबल आहे. आणि जर पर्टिक्युलर कंडक्टर या दोन प्रॉपर्टी जर ओबे करत नसेल, फॉलो करत नसेल, तर त्या कंडक्टरसाठी ओम्स लॉ हा नॉट ऍप्लिकेबल आहे. सिंपल थिंग आहे. देर आर semiconductors such as silicon, germanium, which don't obey that Ohm's law. म्हणजे सेमीकंडक्टरला सुद्धा आपण Ohm's law अप्लाय करू शकत नाही. Are you get it my point? And they are known as a non-ohmic conductors. कारण सेमीकंडक्टर पासूनच डायोड बनवलेला आहे, सेमीकंडक्टर पासूनच ट्रान्झिस्टर बनवलेला आहे. मग डायोडला Ohm's law अप्लिकेबल नाहीये, ट्रान्झिस्टरला Ohm's law अप्लिकेबल नाहीये. इट मीन्स दॅट सेमीकंडक्टर साठी बाय डिफॉल्ट तो अप्लिकेबल नसणार आहे. Are you clear my point? So this is about the limitations of Ohm's law. If you have that any doubt, please raise that doubt. Otherwise, I will move to the next slide is there. Okay. Now, the next point is electrical conductivity of conductors. आता नेमका कंडक्टर घेतल्यानंतर त्याच्यातून इलेक्ट्रिक करंट फ्लो होतो, म्हणजे बेसिक मेकॅनिझम काय आहे, दॅट वी आर गोइंग टू ट्राय टू डिस्कस हियर. ओके. नाउ ऑल ऑफ यू हॅव that focus here towards that your screen and try to listen what I am going to discuss, because this is an important concept here. Now just consider that one piece of a conductor. आता हा रेक्टँग्युलर जो दिसतोय तो अज्युम करा की हा एक कंडक्टरचा पीस आहे. मग तो सिल्वर असेल, तो गोल्ड असेल, तो कॉपर असेल, तो अल्युमिनियम असेल, व्हॉट एव्हर इट मे बी. इट्स अ पीस ऑफ अ कंडक्टर. ओके. Now just by considering the piece of a conductor, can the current will flow through that conductor? Yes or no?
No, sir.
No, sir.
Absolutely no. So what is the requirement to flow the current through that conductor?
Energy source.
Energy source, potential difference. Is it right? So let me try to connect the end of that piece of a conductor, two end of a piece of a conductor to DC energy source through connecting wires. Now these are the connecting wires, and now we just connect the DC energy source in between the ends of that wire is there. Now this is a symbol of a DC energy source. याच्या अगोदर मला वाटतं तुम्ही सर्कल त्याच्यामध्ये पॉझिटिव्ह अँड द निगेटिव्ह साइन बघितलेला आहे. दॅट इज ऑल्सो द सिम्बॉल ऑफ अ DC energy source. And now try to remember that this is also the symbol of DC energy source. Get it my point? Now if you see, have a focus, have a look towards that the symbol of a DC energy source. If you see that at the one side one bigger line is there, bigger vertical line is there, and at the other side the smaller vertical line is there. Have you observed these things? So in that symbol, the smaller line, vertical line, which indicates the negative terminal. So this is the negative terminal always. Get it my point? And the bigger lines at that other end is considered as the positive terminal. This is, we call it the applied voltage. Get it my point? Now see that what happened once we connect that DC energy source. Once again I will repeat, then there is a moment of a free carriers in the conductor, because this energy source will create the potential difference at the two end of a conductor. Now this positive terminal of this applied voltage is connected to this point. Assume that this is the A point, so that this end we consider as a positive end. The negative terminal of a battery is connected to this point. Assume that this is a point B, so this point it acts as a negative end. And as we know that when I consider that the conductor, definitely the conductor consists of large number of free electrons. Is it right? So I think the basic physics you must know that conductor, semiconductor and insulator. Conductor can carry the current easily. Semiconductor, medium, insulator, no current will carry. It depends upon the free electrons. Conductor having the large number of free electrons. Semiconductors having the medium number of free electrons, and the insulators having the no free electrons, so that it will not conduct the current. Now when I say that the piece of a conductor, definitely already the free electrons are present in the conductor, but when the potential difference is applied, these electrons are having the negative charge, so definitely there is a force of attraction between the negatively charged electrons and the positive potential. So that electrons are always try to move. Now this pink color is nothing but the movement of a free electrons. Electrons are always try to move from negative end towards the positive end is there. And when there is a movement of a free electrons, we say that the current it flows through the circuit. So this is the direction of a current. Are you clear my point? The current always starts its journey. The current, conventional direction of a current is always opposite to the movement of a free electrons. Get it my point? So that the conventional direction of a current is always from positive terminal to the conductor towards the negative terminal of a battery. In this way, current always take the closed path. It always take the closed path. म्हणजे करंट हा अप्लाइड व्होल्टेज या डीसी एनर्जी सोर्स पासून स्टार्ट झाला आणि तिथंच एंड झाला. म्हणून तर आपण काय म्हणतो, द करंट, what the value of current, it starts its journey from positive terminal of a battery, the same amount of current should return to the negative terminal of a battery. This is the basic principle of that electric current is there. Clear my point? Now hope that the conductivity part is over. How the electric current, what is the mechanism of an electric current, it's over. Now just give the more focus towards this rectangle. Rectangle is nothing but conductor, and the mechanism when it is connected to that extra DC energy source, what the mechanism occurs inside the conductor, have a look on it. Get it my point? As I said that this point which is connected to the negative terminal, we call it a negative end. And this point, which is connected to the positive terminal of external battery, we call it a positive end. Get it my point? So that electrons, free electrons having negative charge, it always starts its journey. It always try to move towards the positive end. Just assume that here is a one free electron, and when the potential differences exist, definitely these free electrons are always try to move from this negative end towards the positive end. Now just try to imagine that, can these free electrons will move in a complete straight line? Yes or no? Yes or no? If these electrons, which is at the negative end, it move towards that the positive end, definitely during its travel, get it my point, so many obstacles he just faced, or it just faced, these free electrons will have to face. And these obstacles are nothing but another atoms, another molecules, another free electrons. Get it my point? Whatever it may be, म्हणजे ॲटम येऊ शकतो त्याच्या रुटिंग मध्ये किंवा त्याच्या ट्रॅव्हलिंग पाथ मध्ये, मॉलिक्यूल येऊ शकतो. फक्त फ्री इलेक्ट्रॉन्सच प्रेझेंट आहेत का त्या कंडक्टर मध्ये? नो. So many atoms are there, so many free electrons are there, so many molecules are there. The crystalline structure is present. Get it my point? So that when these free electrons move towards that the positive end, it always collide on another atom, molecule, or free electron, whatever it may be. And when it collide, so definitely it rebounds to any direction. मग तो कुठेही रिबॉन्स होऊ शकतो, तो इकडे होऊ शकतो, तो इकडे होऊ शकतो, तो इथं होऊ शकतो. But still potential differences exist. It means that these electrons are attracted towards that positive end. जरी तो रिबॉन्ड झाला तरी पुन्हा तो तिथून पॉझिटिव्ह टर्मिनल कडे अट्रॅक्ट होणार, पुन्हा तो दुसऱ्या ॲटम वरती कोलाइड होणार, पुन्हा तो रिबॉन्स होणार रॅन्डम डायरेक्शन मध्ये, पुन्हा तो पॉझिटिव्ह टर्मिनल कडे अट्रॅक्ट होणार. इन दिस वे इलेक्ट्रॉन्स विल कंप्लीट इट्स पाथ फ्रॉम नेगेटिव्ह एंड टू द पॉझिटिव्ह एंड. It means that during the travel of the free electrons from negative terminal to the positive terminal, so many obstacles are present, and this obstacle present in the conductor is the property of that conductor, is the property of that conductor. And these obstacles are nothing but atoms, molecules, or free electrons, whatever it may be. Get it my point? And these obstacles are always oppose the flow of a free electrons. So because of this concept, the terms comes into picture. So what that terms, that opposition, what we called? Can you guess?
Resistance.
Absolutely correct. So this opposition to the flow of free electron is called as a resistance of that conductor. Resistance, this is the property of a particular conductor. म्हणजे सिल्वरचा रेजिस्टन्स फ्लो ऑफ फ्री इलेक्ट्रॉनला वेगळा आहे, गोल्डचा रेजिस्टन्स फ्री इलेक्ट्रॉनसाठी वेगळा आहे, कॉपरचा रेजिस्टन्स फ्री इलेक्ट्रॉनसाठी वेगळा आहे. दॅट्स व्हाय आय से दॅट द अपोजिशन टू the flow of a free electron is the property of substance. Get it my point? So can I say that here when the free electrons will move from one end to another end, the obstacle is present, opposition is present, and this opposition is called as a resistance of that substance is there. Get it my point? So this concept, it comes into picture when that free electron move from one end to another end is there. So try to read it. Free electrons flows from negative end towards the positive end. During its travel, free electron faces opposition from that another atoms or molecules. During its travel, free electron collides on another atoms, but still it completes its path from negative end to the positive end. Get it, my point? Opposition offered to free electrons is the property of that particular substance, and this opposition is known as what? Resistance of that substance is there. So this concept, it comes into picture right now. Let's have the discuss about that the resistance. So how you can define that the resistance? Can anybody try to create the definition of a resistance?
Property of substance to oppose the current.
Absolutely correct. Absolutely correct. It is the property of a substance. जर तुम्ही फक्त असं म्हणत असाल की opposition to the flow of current, opposition to the flow of free electron, it's an incomplete definition, because the resistance is the property of a substance. A particular substance property आहे, due to which it opposes the flow of current through it. आता फ्री इलेक्ट्रॉन्सला अपोज करतोय म्हणजेच नेमकं कशाला अपोज करतोय? करंटला अपोज करतोय. So that the definition, complete definition is resistance is the property of a substance due to which it opposes the flow of current through it. आता हा खाली जो फॉर्म्युला आलाय त्याच्याकडे लक्ष देऊ नका, त्याच्याकडे आपण नंतर बघूया. But you just have a focus towards the definition. Now, what is the symbol of resistance? This is a zigzag line. As I already said that resistance is a opposition. बरोबर आहे. मग हे zigzag line म्हणजे just like you can consider the speed breaker. The speed breaker on the road. Why the speed breakers are over there? Speed breaker का तयार केलेले आहेत? Definitely it will oppose the speed of a vehicle. That's why the symbol is just like a speed breaker, and the unit, this part is also discovered by that Ohm, so that unit is also Ohm. Is the name of scientist. And if you see that the symbol for that unit, it is also, you can observe that it is also just like a speed breaker. This is my way to remember that this concept is there. Get it, my point? So this is the definition. This is the resistance. Resistance, it can be denoted by the letter R. This is the two terminal component. Get it, my point? And what is its a property? It is the property which will oppose the flow of current. म्हणजे हा कायम करंटला फ्लो करतोय, म्हणजे फ्री इलेक्ट्रॉन्सला अपोज करतोय. Get it, my point? And its a unit is Ohm is there. Okay. So resistance of a material is a different material to material. Just I explained right now. Resistance offered by silver is different. Resistance offered by gold is different. Resistance offered by copper is different. Resistance offered by aluminum is different. कारण ती मटेरियलची प्रॉपर्टी आहे. मटेरियल चेंज झालं की रेजिस्टन्स चेंज झालं. पण जर तुम्ही असं म्हणला की दोन सिल्वरचे पीस घेतलेत, त्यांची लेंथ सेम आहे, एरिया ऑफ क्रॉस सेक्शन सेम आहे, त्यांचं टेम्परेचर सुद्धा सेम आहे, मग त्यांचा रेजिस्टन्स काय असेल?
सेम.
दोन सिल्वरचे पीस घेतलेत, एव्हरीथिंग इज सेम, डायमेन्शन सेम, टेम्परेचर सेम, एव्हरीथिंग इज सेम. सो डेफिनेटली द रेजिस्टन्स इज सेम. पण एक पीस सिल्वरचा घेतलाय,